Okay, good morning, class.
Good morning,
Good
class.
morning.
How are you?
We are
We
very
are fine.
So today we're going to handle computer networking, and it's a continuation from our previous lessons. And today we are going to measure on the network topologies. So the objectives of these lessons are you define the term network topology, and then you explain the various types of network topology. So I will start by confirming if all of us are in. Are we all in?
Yes, we are all.
Yes.
Okay, thank you. So we start with immediate effect. So let's start by defining network topology. So a network topology refers to the physical or the logical arrangement of devices, nodes, and connections in a computer network. It, it defines how the devices are interconnected and how data flows between them. Different network topologies have various characteristics in terms of cost, scalability, fault, and tolerance. So we have said network topology is, is the physical or the logical arrangement of devices, nodes, and connections in a computer. Connections, by connection we mean cables. So the purpose of doing networking is for communication and data sharing. What have we said is the purpose of doing networking, class? Robert?
Okay. The purpose of doing networking is for sharing resources and for communication.
Yeah, that's a good answer. So we go to our next objective, our next subtopic, types of topologies. So the first type of topology we have is the bus, and I'm going to request Doreen to take us through. I'm going to facilitate as you read. So
Okay.
Doreen,
Bus topology. All devices are connected to a common communication media, such as a single cable called a bus. Each device receives all the transmitted data, but only the intended recipient processes it. It is simple and inexpensive to implement, but if the bus fails, the entire network can be affected.
okay, thank you. So as you can see from that diagram, yeah, we have the central cable and the nodes are interconnected. We can see node 1, node 2, node 3, and node 4 connected to the central connector or cable. And at the end of the central connector, we have a terminator. And the purpose of this terminator is to is to prevent noise or what we call, okay, we have some technical issue there. So as I was saying, at the end of the central cable, we have a terminator, and we have said the purpose of that terminator is to prevent signal distortion. So the next type we have is star, and I'm going to request Cornelius to take us through that. Cornelius,
Okay, star topology. In star topology, all devices are connected to a central device, such as switch, Rahab. Data flows between devices through the central device. If one device fails, it does not affect the rest of the network. It provides better performance and fault tolerance compared to a bus topology, but it relies heavily on central device.
Okay, thank you. So as we can see that diagram, we have the central device, that's a switch or a hub, and all the nodes are connected to the central device. So quickly go to our next item, and I'm going to request Suto to read through, to take us through that. Suto.
Okay, the ring topology. In a ring topology, devices are connected in a circular loop where data flows in one direction. Each device receives the data and passes it along the next device until it reaches the intended recipient. It provides equal access to all devices and does not require a central device. However, a single device or a link failure can disrupt the entire network. Thank you.
Thank you. In Ling, we have the nodes are connected in a circular manner, as we can see from our diagram, and each device is connected to another one, as illustrated. So quickly go to mesh, and I'm going to request Anne to read through mesh. Anne.
Mesh, each device is connected to every other device in the network. It provides multiple paths for data transmission, resulting in high reliability and fault tolerance.
Yes, thank you. So as we can see from the diagram, the nodes are connected to each other. You can see the first node is connected to node 2, node 3, node 4, and node 5. So each device is connected to each and every other node in the network. So that's the diagram for mesh. And quickly we're going to highlight on the next item. Our next uh, next item is hybrid topology, and I'm going to request Chemitei Robert to take us through that kindly.
Okay, hybrid topology. This is a combination of two or more different topologies. For example, connecting star topologies with a backbone bus creates a hybrid topology. This allows for more flexibility and can be customized to suit specific network requirements.
So we can say this kind of network allows for more flexibility and can be customized to suit specific network requirements. So this is used in case you have an existing network and you want to create another network for, let's say, for a certain department or a new department. So, and that department has a different network, let's say star, and we add mesh as the existing network. So you connect and you come up the two existing topologies, and you come up with the hybrid topology. So in conclusion, we can say that the choice of network topology depends on factors such as the size of the network, the number of devices, cost, scalability, reliability, and the type of application running on the network. So we are going to do a summary on what we have understood, and I will request each one of you to give 1 point in order. And we start from Cornelius. What have you understood from our lesson today?
Okay, I've understood several types of topology. I've understood about the bus topology. I've also understood about the ring topology. I've also known the hybrid topology and the star topology.
Thank you. I can see you are so active and you've got something at least, and that's good of you. Chemitei, what have you understood?
Okay, today I've understood the meaning of computer networks, what are the types of uh, computer topologies or network topologies, and we've seen that we have the hybrid, we have the bus, we have the mesh, and also we have star topology.
Wow, that's that's a good that's a good summary from the two of you. So I'm going to give you an assignment, and in our assignment you're going to find the advantages and disadvantages of each of the items or topology we have discussed earlier or in our lesson today. Have you gotten the assignment, Cornelius?
Yes.
Yes, we've gotten the assignment.
So you do the assignment, and we go through that assignment in our next lesson. I'll mark, and then we'll go through it in our next class. Okay?
Mwalimu.
Yes.
Okay,
Thank you. Let's meet
Thank
in
you.
our next lesson.
thank you, Mwalimu.
Goodbye.
Thank you.
Have a good day.
Good day to you.